Okay, good morning, everyone. Thank you for joining us today. It is 9:30, so we will go ahead and get started. I just want to thank everyone for joining us today, and we're so excited to be sharing this presentation with you. So just getting started, we want to help you guys get the most out of this webinar. So we do encourage you guys to take as many notes as you can. However, if you miss anything, don't stress about it because we will be sending out the presentation and the recorded webinar out later this afternoon to everyone. If you guys need any help during this presentation, there is a little button where you can raise your hand. If you click on that, that will let us know that there's something wrong and we will reach out to you directly. And then during the webinar, if you have any questions, please feel free to ask them. There is a questions tab on your control panel. If you click the down arrow, you will be able to type the questions. We will be having a live Q&A after the webinar is over, and we will answer as many questions as we can. So joining us today, we've got a lot of people. We've got Jeff Hammond, who is our VP of Technical Services, Mallory Foney, Marketing Director. We've got Tim Wright, VP of Sales, Ed Davis, Residential Sales Manager, myself as a moderator, Steve Smith, CEO and President, Dan Jackson, VP of Operations, and Brian Staley, Assistant Product Manager. Everyone who you see right now will be joining us for the live questions after. So if you do have any questions directed towards them, please just go ahead and type it in the questions panel and we will get those answered. So getting started, we just wanted to give a brief agenda. We want to help set the stage for everyone to understand what's going on today and what we're wanting to present about. We will go over the Advantage system that I know all of you guys are here for, as well as the product features, performance data, field installations, our next steps, and after that, the Q&A. And like I said, if you guys need any help during the presentation, please raise your hand and please ask as many questions as you can. So passing this over to Mallory, our Marketing Director.
Good morning, everyone. Can you guys hear me okay? Nodding heads. All right, so to kick things off, just setting the stage with, how we got to where we are today. You guys probably know, the brief history of air-to-water heat pumps. To start out with, air-to-air was really kind of where the focus was, but unfortunately, they really struggled, those early generation did, with extreme cold temperatures. But luckily, advances in technologies have allowed for air source heat pumps to perform better in those cold temperatures and really really gain market adoption within the US. So that's kind of looking directly at air-to-air systems. Luckily for us, those same advances have applied to air-to-water heat pumps as well. And a bit of a spoiler alert for what you guys will find out later, some of those air-to-water heat pumps include vapor injection and variable speed technology for even further advances. Carly, next slide. Sorry. And then, to kind of dive in a little bit more. So, we've kind of established that air-to-air heat pumps, have really elevated the game within the US, but air-to-water heat pumps are very well established in Europe and China. There's a global market of about 1.7 million units sold a year within the last year. So that's anticipated to continue moving forward and upward in trajectory. Right now within the US, the only real alternative prior to air-to-water were boilers. So there was really no good electric choice. Next slide. So you see here energy independence, other buzzwords like net zero, electrification, clean energy. These are all buzzwords that are gaining with a lot of traction right now. So, and in the US specifically, and in Canada and North America in general, and the world, people are focusing on the reduction of emissions. We've gotten to slide like what, 7 or 8 here, and we haven't brought up COVID yet. But, no surprise, with the current environment, people are really starting to focus on how does my home and building impact my health? Things like allergies, viruses. We have listed here hypertension, asthma, all of those different things. Our environment plays a huge role in how we function as humans. So people are already, before this, we're looking at how do homes and buildings impact me? And moving forward, that's even going to be a stronger indication as to how do I get into an all electric space that's clean, that doesn't use as much, fossil fuel, So that's something that's just going to continue moving upward. You couple that with the fact that many countries, states, provinces, even down to different counties within states are really working hard to eliminate climate emissions. We've listed a few states here. This is only just, a very small handful. I think I read that well over 25 states have pretty aggressive climate emission goals that they would like to hit by 2030, 2025, 2050. So you see here that Colorado would like to lower their pollution levels by 50% by 2030. North Carolina, 40% by 2025. They don't have, very much time to do that. Pennsylvania, 26% by 2025, and New York, 80% by 2050. This product that we're going to discuss today specifically, will have a huge adoption in New York just based off of the fact that it is all electric. That, the work that NYSERD is doing there. Lots of great things coming out of that state that I think will really, set the tone for the rest of the country and North America as well. Next slide. So here we dive into your opportunity. Specifically for HVAC installers, for people just within the space, builders, architects, engineers, those who are just thought leaders within the HVAC space. This is your chance to be on the leading edge of electrification, particularly in North America. Like I said, air to water heat pumps, they're very well established in Europe, China, but here they haven't quite gotten that traction just yet. Mostly because there wasn't a full service solution available. So this is, like I said, really just your opportunity to be on the leading edge of electrification, of net zero living. This is your opportunity to expand your expertise and gain market share before the space is flooded. I know one of the things that I frequently would hear from customers is that when the geothermal tax credit came around, that a lot of installers jumped on the geothermal bandwagon. They maybe weren't as reliable. They maybe weren't as, high quality of work, all of those different things. So essentially, this is your opportunity to create the bandwagon. You get to be the one that really makes your footprint in the space before everyone else jumps on board and starts installing this product as well. Really establish your expertise within the air to water space, and furthermore within, the electrification space, a clean energy home. So we kind of describe this product as a super accessible whole home and building solution. There are instances where other HVAC technologies won't work because of this or that, different ordinances, different reasons, lack of space, all kinds of reasons. And this product could be the solution to that accessible whole home and building all electric solution, for lack of a better term. But also, kind of we'll be diving into this later. Don't, be concerned if you do have a job where it makes sense to include fossil fuels. Maybe the home or building owner still has really great incentives in their area. This product that we're going to discuss has a solution for that too. And I'll let Steve dive in a little bit more here to your opportunity. I think you might be muted, Steve.
I was, thank you. Appreciate that. As Mallory mentioned earlier, there's so many in North America. There's so many, again, either states, provinces, or even local governments that are phasing out fossil fuels, and they are very aggressive timelines. And so, thinking back, when Enertech started in 1996. Enertech, Energy and Technology. And so I would like to think that I was forward thinking 25 years and knew this was coming, that the world would be turning to all electric, but I really can't take credit for that. I was already biased towards electric products as working in the utility side of the business. And so I already had that bias, but anyhow, in all seriousness, the world is trending towards all electric products. You see it in everyday living, and so we feel that Enertech and you, our partners, we are poised to take advantage of that, and we're not backing off any of our passion on geothermal and water source. That's staying just as strong. We're just widening our path as we move forward and offering other technologies. We also added in, which we'll talk about here just a little bit, but this is focusing on the air to water, but we also added solar products because again, the world is trending, we want to be out in front of it. We want to get you out in front of it. So that is our goal. And as I finish up here, I would like to thank our parent company NIBA in Sweden for giving us so much assistance and help on this product. This product is new to us here in the U.S., but it has been in use in Europe for a number of years. And Dan and his engineering team were able to bring it to the U.S. It's pretty much a different product on the inside, but it has a great foundation coming from Europe. So thanks to our partners in Sweden and to help us do this. So again, we look forward to finishing this presentation, and thank you for joining us. And it's a little early. I know it's early in the presentation, but I want to wish everybody a Merry Christmas. Thank you.
Hey, good morning, everybody. Tim Wright, Vice President of Sales. It's great to have you with us today. Thank you very, very much. All of our Enertech family, our Enertech friends. It's just awesome to have this opportunity. As Steve said, we're just showing you how Enertech is widening our path on how we can help head toward electrification and decarbonization. And just wanted to be able to just touch on our tagline or our logo, if you will, for this product. I commend our marketing team by choosing the name Advantage, because really what this is, it's your advantage. It's our advantage. It's our collective advantage. So Mallory and team, awesome job for choosing that name, because it signifies the hope that we have with electrification. So as Steve had mentioned, for our Canadian friends and customers and our US friends and customers, this is a new opportunity to really have a 3-in-1 product, which is absolutely amazing in this market space as we continue to head toward electrification, to head toward that net zero type community. As Steve had mentioned, solar. With this inverter driven technology, that makes it so much easier to bring in solar PV or battery storage. So just as we unfold this today for you, consider Enertech your family, consider Enertech your partner. And this product here is, we're going to unpack this a little bit more with Jeff Hammond next, with more of the technical aspects. I also want to highlight too that we're not leaving out our boiler friends. There's many of you on this call today or on this webinar today that still may be installing boilers. And again, you're doing that. That's part of your profession. That's your livelihood. Jeff will share with you that we have not just brought an all-electric system. We have brought a dual fuel opportunity to give you more longevity out of your boiler, or how this can work in conjunction with your boiler. So Jeff will start and unpack that for us. But to have a system, a complete system, as Mallory said, that will be able to help with all of your radiant floor, as well as your forced air heating and cooling, so that you still can handle all your indoor air quality products. And then again, we say up to 100%. Please understand, for normal usage in a home, this unit will do a beautiful job for you. For those that want a 7-head shower, well, we have a plan for you as well. And Jeff will unpack that. But thank you very much for tuning in, and we're having fun today. This is an exciting opportunity for Enertech, and again, for you folks. Thank you.
Good morning, Jeff Hammond, Vice President, Technical Services. We'll dig into the technical part of this product just a little bit. Feel free to ask any questions that you may have, and we'll be answering those questions at the end. This slide shows all 3 components of the system. And what's great about this is it's a matched system. So there's some unique parts and pieces here on the far left side. The outdoor unit, as Steve mentioned, this is really a NIBA design that we've adapted for the US. So the great part about that is we have a lot of R&D already done. The engineering team has done a great job of taking that product that's been operating for 4+ years in Europe and making it a North American product. So the outdoor unit has some special features. We're using a variable speed inverter drive compressor. So now we can operate at much lower temperatures. It's a monoblock design, which means that section in the lower right-hand corner of the outdoor unit is the entire refrigeration circuit. So we're not running any line sets from the outdoor to the indoor. It's much easier for installation, more reliable, and certainly a quicker installation. So that portion is very similar to a product that's already been in use for quite some time. The indoor unit, the indoor module in the middle of the picture, is an Enertech designed specifically for North America. And this is a huge labor savings. I'll talk about some of the features in the next slides, but as you can see from the picture, it has the expansion tank already installed. There's a Grundfos variable speed pump already inside, zone valves, electric immersion heater, or you can opt for a boiler backup, and instead of the heater, it has a boiler control module. You can also see the large LCD control screen. That's what we call the HMI, human machine interface, and that's a touch screen color display where you can see all of those temperatures and pressures and so forth. The control boards there communicate with the outdoor unit. So this package gives you the complete installation and 1 or 2 days of labor savings just from having all that piping done. On the far right is the indirect water heater. This is a special water heater that we've been using for quite a while with heat pumps, so that it's not new to the air to water technology. As you can see, that big copper coil inside the indirect is unique because it's not like a typical boiler indirect water heater where the boiler water goes through the heat exchanger. In this case, the load water from the heat pump is the storage portion of the water heater, and the potable water actually goes through that copper heat exchanger. So it's more like an indirect water heater. That gives us some advantages in that we can use lower water temperatures, which we would be able to provide from the heat pump, although it can do up to 135-degree water, so it's not that low in that regard. But it's also our storage tank when we go into defrost mode. So when we put all these three pieces together, the system now is really a matched system. We're not trying to source parts and pieces from various vendors and hope that they work together, because everything is communicating from indoor to outdoor. And the outdoor system, the indoor system really is just telling the outdoor unit what it needs. I need heating, I need cooling. And then the outdoor unit takes over and handles all the defrost control. It handles switching from heating to cooling and reports back all the information to the indoor module. So that's kind of a quick overview of the components. Let's go to the next slide and look at some of the features. The monoblock design, as I mentioned earlier, that's a European term, but essentially it means everything is inside a package unit. So we don't have to worry about refrigerant piping, charging, and we don't have any refrigerant inside the home. That becomes more and more important over time as the industry switches to different refrigerants. That'll be even more important. So this type of a design is much more installation friendly. It also allows us to check that unit at our factory in Mitchell, South Dakota. So it gets run tested, just like our geothermal heat pumps. That's a lot harder to do with a split system. Right now, at least, it's the only available package system in North America. What that means is the indoor module is a key part of that. There are other air to water units out there, but they're just the outdoor portion of it. So all of the indoor piping components and so forth has to be done in the field. We think it's about 1 to 2 days of labor savings, because what you end up with are just piping connections. So you're piping to the indoor unit from the outdoor, you have your piping to and from the indirect water heater and out to your hydronic zones. That's really it. You connect your manifolds and so forth. We've also included the hydronic specialties. So you could see from the picture previously, the expansion tank is included, but we ship an automatic air vent, an air separator, and then there are flush ports inside the unit, and we ship a stainless steel flex tubing for the outdoor unit. There's not really much you need from a hydronic standpoint other than the actual radiant manifolds, fan coils, and so forth. The zone valves are inside that indoor module as well. That's a pretty big deal from a labor and piping standpoint. If we want to do domestic hot water, those zone valves switch from the hydronic heating or cooling over to the tank and back. So we're not messing with three-way valves, lots of piping. If we're looking at backup, we have a choice of either an immersion electric heater for all electric systems, or if we have a boiler backup, we can go with a dual fuel module. And in that case, now we're going to energize the boiler instead of that electric heater. The internal variable speed pump is a great feature, very, very low operating costs, and it's communicating with the system as well. As I mentioned earlier, the indoor and the outdoor units communicate. It's via Modbus with just 3-wire shielded cable. Let's go to the next slide. Next slide, please. The outdoor temperature reset is a huge savings in operating costs. There are 15 curves. So based on the outdoor temperature, we can change the minimum and the maximum load temperatures. In other words, the temperature being supplied to the hydronic zones and heating, so that we can operate at the lowest temperature possible for the highest COP. When it's very cold outside, it will max out at the design set point, or when it's in hot water mode, it can go up to 135 degrees Fahrenheit to heat that hot water tank. If we're looking at using forced air heating or cooling, you want to match the system with an Enertech fan coil. Those fan coils are designed for 120 degree water temperature. So we don't need, the boiler 160, 180 degree water temperatures for these fan coils. They're actually designed for the lower water temperatures we get from a heat pump. We offer the zone controls. There are 2 different types. One is for primarily radiant systems with a fan coil for cooling. And we have another zone panel that is designed primarily for fan coils. If you have a retrofit system that's forced air, you can still get all of your hot water, but you can do the forced air heating and cooling with a fan coil or fan coils. And that has a priority system, so it can actually switch back and forth between heating and cooling depending upon what zones are calling. The startup wizard is really a nice touch. We found out on some of the early installations, it even checks to make sure your piping is not sized to too small diameter. So if it doesn't have the flow rate needed, it will tell you during that startup, sorry, I can't get the flow rate that the unit needs. And in some cases, that might mean upsizing the piping. Hopefully we've looked ahead and everybody's attended the training videos, so we know up front what size piping we need, but it does check for that. The boiler backup is a fail-safe type output. So if for some reason the internal pump might fail, then all the zone signals get forwarded directly to the boiler. That's a nice touch. You never know. Anything mechanical has the potential to fail, but hopefully it won't. We still have that protected. We'll still have heating even if a pump is not operating for some reason. The load shed feature is great for those areas where the dual fuel rates are attractive. In Minnesota, for example, the electric rate might be half the cost with a dual fuel setup. And so the load shed is set up where the utility could turn off the unit and we still have a boiler backup for heating. It also works with interruptible power programs. I sat through a California Energy Council webinar yesterday, and there's a lot of discussion on leveling the peaks, doing load shed, managing the demand, but also managing the renewable electricity generation. So this is prime for those types of applications or retrofits where maybe they don't have 200 amp service in the home. All of the pressures, temperatures, water temperatures are shown at the control screen. So from a troubleshooting standpoint, you don't have to hook up any gauges. You don't need your thermometers. You can read those right at the screen. And lastly, the installation manual is about 100 pages. So it has application drawings, wiring diagrams, quite a lot of information in there. The idea is a complete package. So you have everything you need with those 3 components, as well as Enertech support for help on designing the system. So we can go to the next slide now. And on top of all that, it's super quiet. The way that ECM fan is designed and the really, really large air coil outside, you can see here from the sound waves, even when you're within about 6 feet from the unit, you just about can't hear that thing. there's a chart over on the right that compares those sound levels. And if you look down the scale there, a quiet library is about 40 dB. So it's like being in a quiet library. The outdoor noise, traffic, whatever the case may be, is probably louder than the unit. So in this case, it's going to be it will not be disruptive at all as an outdoor unit compared to a lot of air source heat pumps. Next slide, please. Efficiencies are great. This slide shows the efficiencies from -13, which is where that unit can run down to and then shut off, all the way up into the 50s. You can see here, if we have 3 different lines, the blue line would be our typical radiant floor temperatures. They might be lower than that with outdoor temperature reset, but just as a gauge, even at -13, our COP is still 2.5. When you're doing domestic hot water heating, the black line, even at that minimum temperature, is still around 1.8 COP. So it's literally twice as efficient, even at the coldest temperatures, than an electric water heater. When we get into the higher temperatures, you can see we have easily 3 to 4 COP and up to 5 even. So we want to look at bin data for each location, and some slides are coming up later on so you can see that. In most cases in North America, we're going to be operating in that 5 degree to 40 degree range. That's where the bulk of our bin hours are. So you can see the COPs are going to be pretty impressive most of the year. In some areas, we never get that cold even. Next slide, please. Capacities are equally impressive. We take advantage of that vapor injection and variable speed scroll. So you can see the maximum capacity of this 5-ton unit. There's also a 2.5-ton unit, is about 55,000 BTUs per hour. As it gets colder outside, you can see even at the minimum temperature, we still have more than half the capacity. That's pretty unusual for an air-to-air heat pump. We typically are significantly less capacity, even at 0 degrees outside. And likewise, we might be a COP of 1 at 0 degrees outside. So not only is the COP twice that of an air-to-air heat pump, but the capacity is significantly higher as well. With the backup heater or the backup boiler, then we can pretty easily handle that load even at the very cold temperatures. It'll be really important to use the software. We have the GeoAnalyst software available that we'll be talking about shortly, so that we can size it appropriately and look at the best size for that application. Next slide, please. We have 4 cities that we looked at, and this comes right out of the GeoAnalyst software, so that we can compare the various technologies. This happens to be Syracuse, New York. We used average rates for electric, gas, propane, and oil, just so we could compare how that might work. Really, the big savings with the air-to-water unit is what we looked at with capacities and efficiencies. It is a mean heating and a mean hot water machine. So that's where the numbers really come out. You can see here the advantage in Syracuse. Annual operating cost is half of an air source heat pump, half of fuel oil, and we don't even want to talk about propane. So if you're looking for electric technologies, this is going to be a nice choice when it comes to operating costs. The red there is heating, blue is cooling. There's not a lot of cooling in Syracuse, and hot water is the gray area. So it's definitely the lowest cost compared to these technologies. The only other electric technology, the 19 SEER air source heat pump shown here, is still quite a bit higher than natural gas. Okay, next slide. In Quebec City, electric rates are really cheap. There's a lot of electricity in the province of Quebec. So this isn't terribly surprising from an operating cost standpoint, but even versus a 19 SEER air source heat pump, you can see it's not quite half, but it's a good deal less expensive if we're looking at electric technologies. Again, propane and fuel oil, not even in the same ballpark. Okay, next slide, please. This is Minneapolis, where gas is extremely cheap at 20-year lows, and electricity is a little bit higher compared to the other areas that we've looked at so far. So if we were looking at only an electric technology, our only other choice is that 19 SEER air-to-air heat pump, $1,000 more a year. So this is the only thing that can even come close to competing with natural gas. And of course, this is an all-in-one system, so we still have to use natural gas for water heating. We still have to have a separate air conditioner. So one system does it all with the advantage. It's about the only thing, again, that can come close. Now, I didn't do a dual fuel comparison. There are areas in Minnesota with that dual fuel electric rate that would change things a little bit, but since we're focusing on electric technologies and comparing apples to apples from city to city to city, I wanted to be consistent. When you log into GeoAnalyst and play around with the numbers for your particular application, you can look at those different applications and decide, is it all electric? Is it a boiler backup? Which is the best one for my particular application? Okay, next slide, please. In Seattle, it's quite a bit different than Minneapolis from a heating and cooling standpoint. So now, again, this looks like the others, Syracuse, Quebec, and so forth, in that this is by far the lowest cost of operation versus natural gas, propane, fuel oil, and even the 19 SEER air source heat pump. Okay, next slide, please. So this is just a quick overview of the GeoAnalyst software, so you can generate your own graphs. You'll have a choice of the heat pump size, what type of heating system do you have? Is it radiant floor, fan coils, or both? Backup water, your backup heating, your water heater. And so through those choices, you'll be able to create a nice report. Next slide, please. Bin data is what's really most important. This is Syracuse right here. You can see all the way down to -13. We only have 1 hour per year on a 20-year typical weather average here. And if you look at the bulk of the bin hours in that 12 degree to 47 degree range, that's really where our operating is. The way you read these bin reports, you have on the far left, your bin temperatures. Those are 5-degree bins. The next column is bin hours. So those are the average hours per year at each of those bin temperatures. Then there's the building load and the heat pump capacity. So it will show percentage runtime if that unit is not at, if it's not modulating, in other words. So when you see a percentage, that means it's cycling on and off. When you start to see 100% runtime, that means it's trying to match the load. Being a variable speed compressor, it's going to ramp up, ramp down, try to match the load, and also bring on the vapor injection when needed. So it's, in this case, in Syracuse, all the way down to 17 degrees, it's still cycling, which is pretty impressive. When it gets lower than that, colder than that outside, then it starts to load match, and then finally at -3, it runs out of capacity, so it starts bringing on some backup heat. When it gets all the way to -13, that's as cold as it can run, but it doesn't have any bin hours for Syracuse, at least below -13. When we look at colder temperatures like Winnipeg, we would see some hours below -13, and at that point, we would have to depend on the boiler or the immersion heater for heating. Next slide, please. So this is the typical report based on that input, based on the bin hours. You'll have annual operating costs for heating, cooling, and hot water, and then it echoes your heat loss, heat gain, equipment selection, utility rates, and so forth. Okay, next slide. So how do we do it? Well, the key really is the vapor injection. If you look at the operating envelope for the vapor injection scroll versus a typical scroll, you can see we have a much, much larger operating envelope. And what's great about the vapor injection scroll compressor is it can turn on that vapor injection as needed. And in a lot of cases where the bin hours are not as extreme, it'll operate just like any other scroll compressor, although it does vary speed. It'll increase, decrease RPM. When we get cold enough, then it needs, actually this sounds counterintuitive, but it needs to cool the compressor. It's designed for high condensing temperatures and low evaporating temperatures. So what that means is it's cold outside and we're heating domestic hot water, for example. Maybe we're running at 135 degree supply temperature. So it is actually cooling the compressor in those conditions. What happens is it turns on that vapor injection as it needs it for capacity, or it'll turn it off if it's needing a little bit less capacity at those milder temperatures. So having vapor injection helps that compressor operate at much colder temperatures. It increases our efficiencies at those cold temperatures, and we can still operate as just a normal scroll when it's not turned on and have the ability to increase RPMs based upon the load. Next slide. This is just a quick piping diagram. This is one of the ones that are in the installation manual. And you can see here towards the middle of that diagram, we're showing a hydraulic separator. We don't need a buffer tank if we have an air handler that is around 2 tons or larger. We can cycle for the smaller radiant zones, and then we're saving some costs, but also a lot of space in the mechanical room. So we'll have piping with the internal pump, variable speed pump, over to the hydraulic separator, and then our system pump is what provides fluid flow to the radiant zones and or hydronic air handling systems. We have the TurboMax indirect water heater you can see on the right, and we do recommend a backup water heater. In a lot of cases, we'll have high hot water loads, and we also are using that tank for defrost. So the backup water heater is just a nice, inexpensive adder that sort of completes the system. So very simple piping. All of the hydronic components that are internal to the indoor module save a lot of time. And you know, on any hydronic system, that's one of the biggest challenges. In this case, we've got to get over to that hydraulic separator, and from there, the piping is like any other system, really. And so we've saved quite a bit of labor in that case. This happens to be the all-electric version. If we go to the next slide, the dual fuel setup we're showing in the manual with closely spaced T's connected to a boiler backup, and in this case, we can add some heat to that hydronic side when needed. So this would be the dual fuel application. All right, we'll turn it over to Tim for this section.
Hey, Tim, before you get started, I just wanted to let everyone know that we do see your questions and that we will be answering them at the end. And if you do have questions, please continue putting them on there.
Yeah, so certainly thank you, Carly. But real quick, we just wanted to share a couple of the field installations with you. And you see Trenton, Illinois was one of the locations, and then Savannah, Missouri is another location. And it's a beautiful unit. And you obviously see the stand that it sits on. We have 2 different stands available for snow load. But again, very easy, as Jeff said, for the installation from the inside module connecting to the outdoor module. So just trying to show you just a couple of examples of the equipment actually installed, how nicely it is. And on the right-hand side, you do see the TurboMax tank in that upper right-hand corner, if you will, just plumbed in with the hydronic air handler. So beautiful setup, nice opportunity, very nice job on the plumbing side. So again, just wanted to share a couple live examples. Sometimes it's hard to get it in your mind as to what it would look like. So beautiful product. Again, we thank NEVA as well as we thank our design team. Next slide, Carly.
Hello there, everybody, and thank you for tuning in. Good information, Tim and everybody. Next slide here will show John Pendleton, who's our senior trainer. And John's been in the industry for many years. He's been both out in the field for numerous years, but we're proud to have him here at Enertech for at least 5 to 7 years. I'm not quite sure, but it's a significant amount of time. And John just lends a great deal to this team, and we're grateful for that. But his easy manner and his approach make listening to these videos a real treat. He brings home some really good knowledge. We've compiled a 10-unit video library for everyone. And at the end of each video, you will see a short quiz that will have to be taken. And they're self-paced, so you can review them at your own time, your own leisure, go back if you need. But it's imperative that we review the videos, take the quiz to purchase the equipment. That is a prerequisite, and I think it'll be beneficial for both parties to do such. And again, the 10 videos, they will be a little bit later on, they will send a link out to the video library. And if you do need any further help, we're always willing to assist, and orders can be placed starting February the 1st. So if you need anything further, we're all here eager to help, and we certainly do appreciate your time today. Thank you. Next slide.
Hey, Ed, thank you. I am gonna jump in, being from the sales side. We are taking orders now, but what Ed was referencing is when the equipment would actually be coming out to you upon the completion of your video quiz challenge as well as certification. So again, orders, we're accepting those as of today. So thank you very, very much. And if I may, just allow me to unpack this for you with John Siegenthaler. John Siegenthaler has certainly become a friend of Enertech, a friend of electrification. Even all of you folks on the East Coast that do an awful lot of boiler work, John is probably the leading expert as well as mechanical engineer. And his company name is Appropriate Designs. Imagine that. But we are pleased that John has accepted the opportunity and the challenge as an Enertech sponsored 4-part webinar series. We're excited about this, and I hope you are as well. But sometimes the old saying goes is sometimes you have to slow down to go faster. And we really want people to grab a hold of this technology and understand that the basic need, as John has laid out here for us, an overview of modern air-to-water heat pumps. We're going to start that, and you'll be seeing invitations coming out for January the 26th, 2021, 9 a.m. Central Time. Super excited about that. And then we're going to go, that's a Tuesday. So for 4 consecutive Tuesdays, we're going to be bringing this to you through John, but it will be an Enertech sponsored event. But he brings so much experience with him. John is also the author, for those of you that are deeply in hydronics. John has authored Modern Hydronics, and he's also authored the book of Heating with Renewable Energy. So if you haven't seen or heard of John Siegenthaler, you probably haven't picked up a HVAC or plumbing magazine, because he's been authored about 400 times with different articles across this country. So we're so proud that John has offered this up as an opportunity with us. So again, very pleased, but I would encourage you to please tune in with us, spend some time with us. We'll also have Jeff Hammond, possibly even Dan Jackson, on each of those webinars, just in case there's a little bit more product specific, technical questions related. And myself, I will be on there as well. So thank you again for this opportunity. We appreciate it.
Okay, so if you guys have any questions, please feel free to submit them. We will be going through them right now. If everyone wants to turn their cameras back on, I will pass this off to Brian Staley, and he will get these questions started.
Thanks, Carly. And I want to say good morning to everyone, and thank you all for joining us this morning. I want to give a quick hand clap to our marketing team and for those on the presentation this morning. I think they've done a great job. Before I get into the questions, I do want to say some of these questions may require some follow-up, as you know, for further information and so forth. So real quick, I'll get into the questions here. Kind of a sidestep. This is a question probably for Dan Jackson, our project manager, from Daniel Leary. He's taking us back to February in Orlando at the show, and he's inquiring on a small air-to-water heat pump, 12K BTU 1 ton. Dan, he wants to know when that's going to be available.
The 12kW heat pump is actually the 30, what we call the 030. So that will be available upon release. So we have 2 different sizes, nominally named 30,000 BTU unit and nominally named 60,000 BTU unit, and those correlate to a 12 kW and a 20 kW. So that'll be available right away.
Great, thanks, Dan. Got a question from Brian Isolt, how many of the components are U.S. sourced? And some of these questions will bounce back between Jeff and Dan, I'm sure.
US sourced, quite a few actually. And sneaking ahead, I was watching the questions roll in, so this will touch on another question. The compressor we're using is a Copeland compressor, and it's not only a variable speed compressor, but it is a vapor injected variable speed compressor. So that is definitely being sourced here, although I do believe Copeland manufactures it in Europe, but we'll be bringing that manufacturing to the United States as the demand grows. Enertech has always tried to source as much as possible from the U.S. Almost the entire indoor section is sourced from the U.S. There's most of the components that are not U.S. sourced do come from Europe, actually. There are a few, for instance, the outdoor fan motor is actually from Japan, a company called Enertech, which also does a lot of business here in the United States. But that particular model, they do manufacture that in Japan. Many of the electronics are coming from European suppliers due to the fact that they have a little head start on this type of technology. So, and we are also working with our parent company NEBA, as Steve mentioned earlier, and it was just a quicker route to use their electronics manufacturers, even though our electronics are unique to Enertech. It is not something off the shelf that NEBA uses and we just adapted. It runs, there are some physical changes in design of the PCBs, and definitely all of the not all, but most of the software and firmware is Enertech specific. So other than that, all the sheet metal on the outside unit is manufactured in the United States, and with the growth in sales of this product, we will be bringing more and more of those components stateside, as far as the plastic molded parts and things like that. So the further down the road we get, the more we will source from the United States.
Great. Thanks, Dan. We've got quite a few questions coming in, and for time's sake, we're going to try to get through as many as we can before the time runs out for the presentation. And like I said, marketing will be following up, and we will take these questions and we will answer them to the best that we can and provide as much information as well. So moving on, I got a question here from Jake Marin. He says, do you have design options to run at higher temperatures up to 180 degrees Fahrenheit using a boiler to supplement the heat pump during the peak periods? And he states that most buildings have fin and tube baseboards that's going to require higher than 135 degrees Fahrenheit temps during the colder periods. I think Jeff might be able to tackle that one.
Certainly, thanks, Brian. Yeah, it's a great question and a good reason to attend John Siegenthaler's seminars, because he'll get into that in a lot of detail. This heat pump is limited to 135 degree leaving water temperature. So we have a couple of choices. We could go with different emitters, you know, with low temperature emitters, double stack baseboard or something to that effect, or some really nice designed radiating devices, or we can go the backup boiler route. So you can go either way, but the heat pump is limited to 135 degrees, and John will get into a lot of those details on his webinars coming up. We also have some drawings in the IOM that show boiler backup piping.
Great. Thanks, Jeff. Got a few questions here asking about the presentation. Mark, and we'll be following up with the link to the presentation for you guys to view at a later date. So you should be looking for that later this afternoon, if I'm correct, right, Carly? Okay. I got a question for Jeff. What is Jeff using for heat loss gain for his comparison of operating cost?
That's a good question. Yeah, we used an 1,800 square foot home in each of those areas. And so those are estimated heat loss, heat gain but if you're doing a manual J or F280 calculation, you can add that heat loss, heat gain right into GeoAnalyst, and that will provide the operating costs as well as the kilowatt hours, gallons of propane, what have you.
All right, great. Rob Dirksen asked, I noticed there was auxiliary heat consumption throughout the heating vent temperature ranges. What does this actually represent?
Great question. Yeah, defrost is represented by those kilowatt hour usage in the 42-degree range and lower, and that's because when the unit's in defrost, we have to make up for the heating in some other means. So we do have some electric or boiler operation in those cases.
Great. Got a question from Jake Marin for, this might go to Tim actually. Do you sell product through any distribution channels, particularly in the Northeast, or do we sell direct only?
Yeah, that's a fantastic question. So we truly believe that this new air to water, this Advantage product, will bring new distribution opportunities. So I welcome you to please reach out to us. It will go through some of our dealer direct opportunity channels in New York, for example, dealers that are already installing our geothermal products as well as solar PV. They'll have access to that through Enertech, but we're also certainly looking for distribution opportunities. So we welcome that. So again, please reach out. Thank you.
All right. Got some questions here about tech literature and pricing. Marketing is going to be releasing some information about all the literature that's going to be involved. Yeah, the installation manual, the submittal, and the price books all going to be referenced, and where you can locate those out on our branded websites or support site, wherever they may be located. So keep an eye out for some follow-ups from marketing, because they're going to have some valuable information for all you guys.
Brian, I'm going to jump in really quick. Just do keep in mind that this is an Enertech branded product. So that's, one new and additional exciting thing about this product is that it actually is branded as Enertech. So, in the past, if you are a Hydron or GeoComfort customer, there is some data available on those sites. But actually, if you head to the Enertech website, that's where you'll find all that you need to know about the Advantage system. So just kind of keep that in mind as you guys, search out that information. And like Brian said, we'll be sending everything out. But that's something to just kind of keep in the back of your mind. Great.
Thanks, Mallory. Question for Jeff or Dan. One size Turbo Max for both the 2.5 and 5 ton?
Well, there are two sizes available. There's a 45 gallon and a 65 gallon. And that's available for either the 030 or the 060. There is only one indoor module for both units. So you'll pair the outdoor unit, the indoor module, and either a 45 or a 65 gallon water heater.
All right. Another very important question, Jeff or Dan. Have the units been rated for AHRI or NEEP? I knew that one was coming.
Dan, do you want to take that or do you want me to?
Yeah, I'm sorry, Brian, could you repeat that?
Yeah, have the units been rated for AHRI or NEEP?
Oh, no, we've not done any rating as of yet. We did check with AHRI and we would have rated it with AHRI, but there is not a section or sector in AHRI that fits this type of product. You can rate it, I believe, under the chiller sector, but there is no heating rating, and being a heat dominant unit, as of yet, there really isn't. There really is a section under AHRI. So as soon as there will be, or as soon as there would be a box that fits in, we will definitely rate it there.
Okay, thanks, Dan. Are we aware, John Sands is asking, are we aware of any issues installing on and off grid battery systems?
I can take that one. I'm not aware of any. This is a great product for net zero because we can go all electric, and then we will optimize our modules and battery storage accordingly. So that's one of the nice features with this product. With that internal 9 kW heater, we can help you design your solar package and select the inverter and the battery storage that makes the most sense. You can choose, depending upon the utility program or how you want to handle your amount of storage. Certainly, it can be complete net zero. You might want to just offset certain peak demand rates. You might want to have storage for nighttime use. So there are many different ways we can operate with this product and solar/battery storage.
Great, thanks, Jeff. Got some questions about the vapor injection, one specifically from Michael Simpson. Can we direct him to a website to learn more about vapor injection? And I'm sure Tim and Jeff can explain more. I believe our training is going to have some information about vapor injecting specifically, if I'm correct.
That is correct. One of the 10 videos that will be online at Enertech University will cover vapor injection, but Copeland also has some nice materials online, and that's a good place to learn about it. I would start with the Enertech University videos. You can certainly contact technical support, and we're happy to help out. It's really an interesting technology. Once you look at the installation manual, there are some refrigerant diagrams in there, and you can see what happens when with those various operating modes. But yeah, there's a lot of good information online. I would start with the Enertech University and then go from there.
Great, thanks, Jeff. Just a couple more questions. We're running pretty short on time here. Question for Jeff: can this be used with radiant floor and with air handlers?
Absolutely. Yeah, we would pick a zone control that would allow us to do that. So we would have our outdoor temperature reset curve for the radiant floor, and then when there's an air handler call, we would default to the 120 Fahrenheit temperature for our fan coil. So we can use that fan coil in a couple different ways. It can be an auxiliary source. It can be used in the spring and the fall when we have our radiant floor system not operating, or it can be used for just cooling. So we definitely can do that.
Great. One last question, then I'll turn it back over to Carly. Does radiant floor temperature change with the outdoor temperature?
It does, and that's built in. So there's an outdoor temperature sensor already installed at the outdoor unit. The indoor module looks at that outdoor temperature, and it looks at the settings. You set your minimum and maximum temperatures on the indoor touchscreen, color touchscreen, and based upon your selection of your 15 different curves, it's going to change the temperature delivered to the radiant floor based upon the outdoor temperature. It still uses a fixed temperature for domestic hot water and a fixed temperature for fan coils, but anytime there's a radiant zone call, then it uses the outdoor temperature reset. If you have that turned on, you certainly can turn it off. Maybe you have a staple up radiant or something like that where you don't want to lower the temperature, but in most cases you will want to use that outdoor temperature reset, and that's built into the indoor module.
Great. All right, well, for time's sake, we're going to go ahead and turn it back over to Carly. And any questions that were not answered, do apologize for that. We had quite a few come in all at once, and I know everyone's interested in what's going on with the product. And like I said, we will try to follow up with some further information on these particular questions. So once again, thank you all for joining us. Thanks, big support and big hand clap to the team for the great presentation. I'm going to turn it back over to Carly.
Hey everyone. So this will be sent to you via email. You will get the webinar recording as well as the presentation slides. If you guys have any questions, please feel free to email them in. And the email will have all of your links, all of your handouts, anything that you guys would need. And then, like Brian said, we will reach out directly to you for some of the bigger questions that we did not get to. So with that being said, Tim, Steve, Dan, Jeff, do you guys have anything else you wanted to add?
Yeah, Carly, I'll just jump in. Just want to thank again everybody for taking time today to spend time with us to learn about this product, learn a little bit more about Enertech and our culture. And hopefully you've seen through this hour and a half just our willingness to help you from the design process all the way through installation to make sure that you have satisfied customers. So thank you. Challenge you to strongly consider John Siegenthaler's upcoming series, and then obviously imperatively to join in on the Enertech videos and make sure you've got your certification before we can allow equipment to go out the door. So very excited. A lot of distributors also, Enertech distributors, want to handle this product, and we'll be seeing their orders soon as well. So again, thank you. Merry Christmas and a very happy New Year. Thank you.
Yeah, thanks everybody. We appreciate it. And again, this is a new chapter for Enertech. As I mentioned earlier, we're broadening our offering. We're not changing our path from geothermal or water source. We've just added to our passion. So we're excited about this product, and we can't wait to get it out to you. So again, Merry Christmas and Happy New Year, and thank you for taking the time. We appreciate it.
Okay, with that being said, we are going to go ahead and end the presentation. Thank you, everyone.
Thanks, Carly.
Thanks, Carly. Bye-bye.